In this class, I like to discuss eigenvalues of a square matrix. Eigenvalues of a square matrix. Square matrix. Suppose we have a square matrix A. Then we know that how we can then we can find its characteristic equation. A's characteristic equation. Then its formula is determinant of A minus lambda I equal to 0. This is the characteristic equation of the matrix A. Then we know that this will be an equation. Then eigenvalue is defined as roots of characteristic equations are called eigenvalues of the square matrix. If we find the roots of this characteristic equation, that is called eigenvalues of the square matrix. For example, we have a matrix A equal to 1, 3, 0, 2. Then we know how to find its characteristic equation of A. That will be characteristic. In the last video, I discussed two methods to find characteristic equation. So we can find characteristic equation in the shortcut method by, that will be like this: lambda square, since it is 2 by 2 square matrix, then lambda square minus sum of diagonal entries, that is 3 lambda, plus determinant of the given matrix is 2 equal to 0. This will be the characteristic equation of A. Then eigenvalue is the root of this equation, this quadratic equation. We can find its root by several methods. I am going to use the easiest way, that is, we can rewrite this quadratic equation as lambda minus 1 into lambda minus 2 equal to 0, since minus 1 into minus 2 equal to plus 2 and minus 1 plus minus 2 equal to minus 3. So we can rewrite this characteristic equation as lambda minus 1 into lambda minus 2 equal to 0. From this equation we will get lambda equal to 1 or lambda equal to 2. Lambda equal to 1 and lambda equal to 2 are called eigenvalues of the matrix A. I like to find characteristic value of 3 by 3 matrix. I am going to consider this matrix, that is 3 by 3 matrix 0, 1, 0, 0, 0, 1, 6, minus 11, 6. This is a square matrix, and in the last video I discussed how to find characteristic equation in two methods. Any of the method we can use. By using that method we can find its characteristic equation. Then, and also that characteristic equation of this matrix will be like this: lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. This will be the characteristic equation of the given matrix A. Okay, now I am trying to find roots of this equation. Since it is a third-degree polynomial equation, there is no exclusive formula to find roots. There is no formula to find roots of the third-degree polynomial equation. So I am going to use some techniques. First technique is, the root must be the divisor of the constant. Root must be the divisor of constant. We know that there are 1, 2, 3, minus 1, minus 2, minus 3 are divisors. I am going to choose the first number 1. Now I am going to check that 1 is the root of this equation. To check, we put 1 lambda equal to 1 in this equation. Then we will get 1 cube minus 6, 1 square, that is 6, plus 11 minus 6 equal to 1 minus 6 is minus 5 plus 11 is plus 6 minus 6 is 0. Therefore lambda equal to 1 is one of the eigenvalue of this characteristic equation. One of the eigenvalue, lambda equal to 1, is an eigenvalue of the E of the matrix A. Now I need to find remaining two more eigenvalues. To find two more eigenvalues, I am going to rewrite this characteristic equation is in the form of lambda minus 1 into a second degree equation equal to 0. I am going to rewrite this characteristic equation to this form, that is lambda minus 1 into a polynomial equal to 0. Since we are going to rewrite this equation, that is a third degree polynomial equation, and here there is a first degree polynomial, then this must be a quadratic equation, second degree polynomial. So I am going to find a quadratic polynomial lambda square, lambda, a constant term. To find this quadratic equation, we need to find its coefficients here, and a constant. We need to find these two numbers. I'm going to use a technique to find these coefficients of this quadratic equation. That is like this. Since lambda equal to 1, you note that lambda equal to 1 is one of its roots. So I am going to draw above something like this, something like L, and we know that lambda equal to 1 of its eigenvalue. So I am put 1 is here. Next I am putting here the coefficients of this characteristic equation, that is coefficient of lambda cube is 1 minus 6, coefficient of lambda square is 6, and coefficient of lambda is plus 11, and the constant same is minus 6. Okay, now I put a 0 here. Then I am going to add these two numbers, that is 1, that is 1 plus 0 is 1. Next step is I need to multiply 1 and 1, that is 1 into 1. 1 into 1 is plus 1. I write its product here. Then again I am going to add these two numbers. Then we will get minus 5. Then I am going to multiply 1 and this minus 5. Then result will be minus 5. Then I am going to add these two numbers. That is, there will plus 6. Then again 1 into 6. That will be plus 6. Then if we add the last two, minus 6 and plus 6, we will get 0. The last number will be a 0. So I found the coefficient of this quadratic equation. That will be 1 is the coefficient of lambda square, minus 5 is the coefficient of lambda, 6 is the constant term. So we can write this polynomial like this: lambda minus 1 into lambda square minus 5 lambda plus 6 equal to 0. So I wrote this characteristic equation like this, that is lambda minus 1 into lambda square minus 5 lambda plus 6 equal to 0. Next step is I need to find the roots of this quadratic equation. I can rewrite this equation like this, that is lambda minus 2 into lambda minus 3. Here already we have lambda minus 1. Since minus 2 into minus 3 is plus 6, minus 2 plus minus 3 is minus 5. So our characteristic equation is lambda minus 1 into lambda minus 2 into lambda minus 3. So for characteristic values are lambda equal to 1, lambda equal to 2, and lambda equal to 3. These three values are characteristic values of the given matrix A. Now I like to introduce a definition, which is triangular matrix. Okay, a square matrix A is said to be a triangular matrix. A square matrix A is said to be a triangular matrix if non-zero entries are only in diagonal entries or upper side of the diagonal entries. Non-zero entries only in the diagonal entries and its upper side, or non-zero entries are only in diagonal entries or lower part of the diagonal entries. For example, A equal to 1, 2, 0, 3 is a triangular matrix since only non-zero elements is is only in diagonal entries or upper side of diagonal entries. Remaining elements are 0. In 3 by 3 matrix 1, 2, 3, 0, 5, 6, 0, 0, 0. This is also a triangular matrix since only non-zero entries are in upper side of the diagonal entries and upper side of the diagonal entries. And this is also triangular matrix 1, 2, 3, 1, 0, 6, 0, 0, 0. This is also a triangular matrix since non-zero entries only in diagonal entries and its lower side. This type of matrices are called lower triangular matrix. This type of matrices are called upper triangular matrix. Then theorem says that if A is a square matrix which is triangular matrix, either it is upper triangular or it is lower triangle, whatever it is, its eigenvalues are diagonal entries. Eigenvalues are diagonal entries. For example, if I take the lower triangular matrix, we know that this is a lower triangular matrix. If we form its characteristic equation, then it will be lambda square minus 3 lambda plus 2 equal to 0. Then we can find its root, that is lambda minus 1 into lambda minus 2 equal to 0. That is minus 1 into minus 2 equal to plus 2. Minus 1 plus minus 2 equal to minus 3. Therefore, eigenvalues are lambda equal to 1 and lambda equal to 2, which is exactly the diagonal entries. That is, if we need to find eigenvalues of a triangular matrix, then we don't want to form its characteristic equation. They are just diagonal entries. Eigenvalues are just diagonal entries.